Hey, you guys, welcome back. Hopefully that first video made sense. We are going to continue on page 256, the consolidation. You will notice at the top of page 256, we have the graph of the most basic parabola, y equals x squared. I have it up here on the screen as well. Please, if it isn't open, go ahead and open that graphing calculator, top right. Make sure you hit graphing right here on the bottom. So why do I call this the most basic parabola? Well, the only rule to be quadratic, the only rule to create this parabola U shape is that we have a highest exponent of 2. And you'll notice that's exactly what we have in this equation, a highest exponent of 2. There's no rules that say to have a parabola, I have to have a number in front of x squared, a coefficient. There's no rules that say I have to add or subtract anything else. I simply have to have a highest exponent of 2. So many times we will call x squared, we will call it, and I'll show you my workbook here in a second, we call it the parent function. The parent function or the parent graph of any parabola. We call it the parent because everything we do, we compare it back to x squared. So number 1 says to plot each of those 5 graphs, except I'm going to change the instructions for both 1 and then 1 and 3. And each of these sets, if you want to sketch the graphs, awesome, please do that. Graph them here on your computer, sketch the graphs. You probably definitely want to label them, but sketch the graphs on there. What I want to be able to do is identify which one is the skinniest and arrange them from the skinniest all the way to the widest. So that means we are going to have to do a little bit of review. So I am going to flip around my computer here. We are going to have to do a little bit of a review from what we just learned in the previous video of what it means or how we create a parabola that is wider. So I set up here x squared. This is my parent function right here, most basic parabola. We said previously, remember that reminder I gave you, if you work out twice as much, what happens? If you work out half as much, what happens? We said for a values that are bigger than 1. So 2, 3, 7, 10. If you work out twice as much, 10 times as much, you are going to get skinnier. And if you have a values that are between 1 and 0, they are your parabola. If you work out a third as much, if you work out half as much, you are going to get wider. Now, why do we say that these a values have to be between 0 and 1? Well, think about if I went past 0. That would get us into negative a's, and a negative a flips my parabola over. Any other number besides, well, the negative, you could think of the negative as a -1, but any other number, if I had a -5, a -1/3, I'd take that number and I would decide, am I going to get skinnier or am I going to get fatter? So moving on to number 1, which parabolas are going to be the skinniest? Which parabolas are going to be the widest? There is our number 1. You do have that graphing capability on your computer. So if you want to verify anything, please pause the video. Go ahead, type in each of those into your calculator on the computer. But based on our reminders, our shortcuts up here, I know that the ones that are going to be the skinniest are the ones that have numbers bigger than 1. So going down 2 is definitely going to be a skinnier graph. I'm going to put an S in front just to remind me. 3/2. Now, some of you may look at this and say, oh, 3/2, that's a fraction. A fraction is small, it's going to make it fat. But think about the fraction 3 divided by 2. 3 divided by 2 is actually 1.5, and 1.5 is bigger than 1. I'm going to get skinnier. 5/2. 5 divided by 2 is 2.5. Oh, bigger than 1. It's going to make me skinnier. So please don't think fraction means fatter. Fraction means wider. Not the case. Make sure you know what that fraction is equivalent to. 3 is going to make us skinnier. 4 is going to make us skinnier. So all of these are skinny. Does that mean they are going to be the exact same amount of skinny? You know what? I'm not going to graph all of mine in my computer. I'm going to flip this over. I am just going to graph some of them here in my computer. I am going to show you how do you put in more than one equation at once, because that can be really helpful. I guess I don't need x squared. I'm going to go with the first one, 2x squared. There, it got skinnier. What if I want a second one? If I want a second one, I'm going to go right here by the 2. I'm going to click, and I'm going to type in y equals our next one, 3 divided by 2. I'm going to arrow out of that 2, x, and hit the up button to get the squared. There's my x squared. Now, if I want to change the color, first one's red, second one's red, I'm going to click on that second one. Oh, nope. Just kidding. I knew there was a way somewhere. I guess I forgot what it was. If I come up with it later, I'll let you know. I guess we'll go with the red right now. If I want to add a third, I can add it on here. But you will notice also if I click on that, it actually makes it disappear. So here's our 2x squared. I'm going to turn back on the 3/2 x squared. What do you notice? Is 3/2 x squared wider than 2x squared, or is it skinnier? And we can tell as I turn this one on and off that the 3/2 x squared is wider. Now 3/2 we said is 1.5 x squared, and it is wider than 2x squared. Why do you think it is wider than 2x squared? Well, let's keep going. Let's graph a couple more. I am going to graph the third one. Actually, I don't know. I put a 7 in there. Y equals, yeah, we'll go with it. 5 divided by 2, arrow out of there, x squared. Okay, there's a lot going on here. I can actually drag this graph down so I can see a little bit more if I want to. I can zoom in if that helps a little bit. Okay. Whoa, I zoomed too far. Here we go. Click, set that down. Okay. I'm going to turn all my other graphs off. 2x squared, 3/2 was wider, and 5/2 was the skinniest. Did you notice that? I'm going to get rid of the other ones. I only have 5/2 right now. There's 3/2 wider, and 2x squared is right there in between. I'm not going to worry about the other two yet. I'm going to let you make a decision about those, but I'm going to flip this back around for you. Let's talk about what we just noticed. Okay, so we have said 3/2, same as 1.5, wider than 2x squared. 5 divided by 2 is actually 2.5 x squared, and it was the skinniest of the two previous one. Skinnier than 2x squared and 1.5, 3/2 x squared. So I want you to go ahead and graph or make some sort of judgment about 3x squared and 4x squared. Again, our goal. Can we put these from the skinniest to the widest? Pause the video if you need to, make a judgment about the remaining ones, and then unpause it and we'll see what happens. Okay, so you've now graphed and you realized that 3x squared is actually skinnier. Is the skinnier than 2x squared, 3/2 x squared, or 1.5, and 5/2 x squared. And we'll notice that 4x squared is the skinniest. So if I put these in order, the skinniest, they're all skinny graphs, but the skinniest is 4x squared. And then 3x squared was the next skinniest. And then 2.5 or 5/2 x squared was next. And then 2x squared. And although all of these are skinnier, last but not least, 1/2 x squared or 3/2, although all of these are skinny graphs because they are skinnier than the parent function x squared, the widest of these skinny graphs was the 1.5. So what do you notice? The larger the number, the skinnier you are. The smaller the number, the less skinny you are. The larger the number, the skinnier you are. Larger the number, the skinnier you are. If you want to make a note here, up here, go for it. The larger the number, the skinnier you are. So if I added, let's say, 7.5 x squared to this list, 7.5 is larger than any of these other coefficients, so 7.5 x squared would be the skinniest. Let's say I added 1.25 x squared. 1.25 is smaller than any of these coefficients, so it would be the widest of my skinny graphs. The larger the coefficient, the skinnier you're going to be. So then let's take a look at all of these in number 3. In number 3, we'll notice 1/2, 0.5, 1/3, 0.3 repeating, 2/3, 0.6 repeating, 1/4, 0.25. You know what? It would probably help if I wrote these down. 0.5 x squared, 0.3 repeating x squared, 0.6 repeating x squared, 1/4 is 0.25 x squared, and 3/4 is 0.75 x squared. All of these are fractions. Again, if you work out a quarter of what you do now, you're going to get wider. All of these graphs are going to be wider than x squared. All of these graphs are going to be wider than x squared. But which one is actually going to be the widest? The widest. And while they're all wide graphs, of these graphs that are wide, which one is going to be the skinnier of the wide graphs? I want you to pause the video, graph these in your computer if necessary, make a sketch over here if you want to, make a judgment of these graphs that are going to be wider than x squared, which one is the widest, the fattest of all of them, and which one is really the skinniest of the fat graphs. Use your calculator, use your computer if you need to, and then unpause the video. Well, what you probably noticed, very similar to our previous, the larger the number, the skinnier the graph. The smaller the number, the wider the graph. That is going to carry through. The smaller the number, the skinnier the graph. The smaller the number, the wider the graph. Smaller number, wider graph. I'll actually make myself a note. Smaller number equals wider graph. Smaller number equals wider graph. For me, comparing or figuring out which one of these numbers, which one of these coefficients are smaller, way easier looking at the decimal. So if I look, the smallest number up here is 0.25. 0.25 is the smallest number. If I only work out 0.2 of what I do now, I'm going to be really wide. So I'm going to say my widest graph, use your calculator, your computer calculator to verify, should be my widest graph. So now looking at, if I kind of cancel that one out, looking now, the smallest number that remains is 0.3 repeating. So 0.3 or 1/3 x squared has got to be my next widest. So there's 2. Our next smallest number would be the 1/2 or 0.5 x squared. That would be our middle of our wide. Next would be 0.6 repeating x squared. And that means our skinniest of all of these, our skinniest of all of them is 0.75 x squared. Now I realize since all of these numbers are between 0 and 1, our graph technically got wider, but it still actually continues with our summary we said before that the larger the number, the skinnier you're going to be. 0.5 is the largest of our coefficients in number 3, and it is the skinniest of our graphs. The larger the number, the skinnier you're going to be. The smaller the number, the wider you're going to be. Okay, at this point, we have finished up all of the notes. You are going to have a couple questions that I'd like you to do as homework. You can see what those are on Canvas. And then if you've read through all of the instructions on Canvas, you know that I will be available later today for questions. You're welcome to email me at any time, but if you want to ask me questions live, if you will, on a Google Meet, you are welcome to do that. But continue reading for more instructions on Canvas.